Welcome to Staking University's Locator Training Program. We have two goals for you in this training material. Number one, we want you to learn how a locating instrument works. And secondly, we want you to know how to use a locating instrument. It's important to understand that all of these instruments work on the same principle. And it doesn't matter whether you're locating a pipe, a wire, or a cable. The instrument does not know. And while we've kept the GoPro on the receiver, it's important to understand that a locate is made at the transmitter end, because without current on the line you're trying to locate, you won't build fields, and fields are necessary for the receivers to do their work.
So let's talk about some of the labeling that we're going to use in this training product. If we're drawing out a gas line, it will be yellow. An electric line will be in red. Telecom lines will be orange. And water will be blue.
Our gas lines are sometimes steel, sometimes plastic, but all the plastic lines have tracer wires. Our electric distribution is mostly three-phase, and there are underground splices. Our telephone system is both copper and fiber. And our cable television is coaxial cable. All of our water mains are cast iron. They were installed during the 1940s. We've chosen to utilize an array of frequencies in our videos. We'll utilize red to show you low frequencies, which are any frequencies below 1,000 hertz. We'll use orange to indicate a high-low frequency. Yellow signifies a low-high frequency, which is from 10 kilohertz to 200 kilohertz. And then 200 kilohertz and above, we'll utilize green. Those are high frequencies.
We use green to signify the transmitter's energy, no matter whether it's on a line, in a field, or traveling through Earth.
This is a pumpkin-shaped field. We utilize this to show the energy that comes out of the transmitter on induction. We'll be utilizing green orbs to show you how the signal can split on the utility system that's being located. Depending on the way current is flowing on these conductors, we may see indications on the receiver that result in an inaccurate locate. In situations when there are many metallic conductors nearby, it's the proper use of the transmitter and knowing how you can change things on the transmitter end that will help you reduce the number of metallic objects that are energized. Current builds fields. The receiver detects fields.
Different receivers have different numbers of antennas. And where those antennas are positioned within the receiver can vary between manufacturer.
But despite the differences in antennas, the user should expect, no matter what manufacturer's equipment they utilize, that everything we do in these videos applies to your instrument. We often make use of the same site in multiple videos. Usually, we'll be locating a different utility when you see the same site again in the training videos. We'll place a compass on our video quite often so that we can keep directions in a north, east, west, south perspective. In addition to GoPro camera shots, we also make liberal use of drone photography. Occasionally, we'll show you glimpses of the utility maps for the utilities in the area of our filming. Our maps will always have north at the top. We'll utilize diagrams, arrows, highlights, numbers to try to keep you focused on the concept that we're presenting. While all our videos have themes, we oftentimes reinforce the things that were brought up in previous videos. We do this because the opportunity presents itself and because some concepts are so important, it bears repeating, sometimes over and over. We want you to understand how an instrument works and how to use it.